All right, so let's look at what we're doing today, and then we'll play with that midway through the period. I do want to go over number 74 from the homework first, and then I'd like to spend a few more minutes on the problems that I gave your new foursomes last time. After we do that, we'll go over the rest of the homework, and then we'll go ahead and play around with these 4 ramps, and then I think finally we'll finish talking about torque and center of mass. I'm just getting a little tired of putting those in the notes each time. What else? I do think that I'm totally done with second marking period grades. In fact, I had absolutely nothing in your folder. I had some stuff in the other sections folder. Other questions, issues, problems about anything before we take a quick look at 74? All right, so 74 we were pretty successful with, but I'm not sure that all of your approaches would work for all problems that we'd encounter. All right, so if you have your book, it's on 308. I'm going to take a couple of shortcuts that really show you most of my work. All right, so we're supposed to draw a sketch first. The sketch is really already in the book, but we have this boulder that rolls down the hill, and we want to know things about its mechanical energy. And what were we told? We were told that the mass of the boulder is 20 kilograms. It's starting 100 meters above where it finishes, so I'm calling that the initial height. And then we want to find in part A how much gravitational potential energy it has. I think all of your solutions were absolutely fine for that. Right? The gravitational potential energy at the top, or initially, certainly is its mass times our gravity times the initial height. So that's 20 times our 9.81. I'm going to continue to not use negative values when I calculate the potential energy. And then it has 100 meters worth of potential energy. So I got 19,620 joules when I did that one significant digit, which is why I posted 20,000 joules as my answer. Follow-up issues from anybody about part A and calculating how much energy we're storing in this thing by giving it the ability to roll down the hill. All right, part B is where I think some of your solutions are a tiny bit dangerous. So in part B, we want to know how much kinetic energy it's going to have at the bottom, right? When it gets down to the base, how much kinetic energy is it going to have? So this, I think, should be a conservation of mechanical energy approach. It's probably invalid that mechanical energy is really conserved here. There is going to be friction. This is going to run into things. But I don't think there's any other information that could give us a different approach. So I am going to make that kind of gross assumption that mechanical energy is conserved. And it certainly does have potential energy at the start. In fact, we already calculated that. I'll go ahead and put that value in. It has no kinetic energy right at the beginning. It's starting from rest, so I can put in a 0 there. If it is going all the way to the bottom, then it should have no potential energy at the bottom. And then the kinetic energy is what we wanted to find. So the kinetic energy in this example is equal to the potential that it had at the top. That wouldn't always be true. If we wanted to know about its kinetic energy, like here for instance, then we certainly can't just say that all the kinetic here is equivalent to the potential up there. But for this problem we could. So I had 20,000 joules for the kinetic energy at the bottom. Follow-up issues about my conservation of mechanical energy approach for part B. Last question. All right, and then for part C, we wanted to find the speed that the boulder would have at the bottom. So here we are just going to use our expression for kinetic energy. It's 1/2 the mass times the speed squared. We knew how much kinetic energy we had, 19,620. The mass was 20, and we want to find the speed. So I can, I suppose, take care of my 1/2 times 20 first. That's like 10. And then I can divide both sides by 10. And then I do need to do square root. And I had, 44.3. But that should only have one significant digit, which is why I rounded my answer to 40 meters per second. Any other issues from you guys about 74? Okay, so let me just turn this off. I don't know if I'm fully charged, and we don't need it again till later.